Alright, so you've had some practice with Lewis structures so far, but we're going to go over it if we're still a little bit confused. So, the objective of Lewis structures is that we want to be able to write them knowing what we know about electron configuration, and you want to be able to do it for molecules that's only covalent with multiple bonds. So a Lewis structure represents how a molecule or a polyatomic ion, which we'll study later, is arranged with the valence electrons, how they bond together. And then only the valence electrons are shown. You don't draw every electron. And the electrons are shown as dots in the valence structures for the entire bond. So in an ionic compound, you don't have any dots around the metal because the metal gave up its valence electron. And then the nonmetal is shown with a full shell because you transfer the electron to show a full shell. And because it's a transfer, they're not sharing it. They're going to be separated like this. And then the on the outside because of the brackets. So if you give away the electron, you're going to have a positive charge. And then the one where you got an extra electron, the chlorine, has a negative charge around it. Covalent bonds are a little bit different. So hydrogen wants what they call a duet. You want to share your two electrons. So this is hydrogen bonding with another hydrogen, and they're going to share like that. So you have your H's with their valence electrons facing each other, and then you just put them together like this. You don't connect it as a line, you just show them on top of each other as a bond. So in the blue right here for fluorine bonded together, you see that the electron pair that's shared is right in the middle, but you don't draw a line. Fluorine wants an octet, which is why everything shares. It gives it a full shell. So you share it with another fluorine, and that makes F2. It's called a diatomic model. The electron pair between the two atoms is called a bonding pair. So that's what's actually participating in the bonding. And they're not between two atoms. Those electrons are unshared. So those are called your lone pairs. They're lone even though they're in pairs because they're not participating in bonding. So each fluorine has one shared pair and 3 lone pairs around it. So here are some tips for writing the structures. Include all of the valence electrons from the atoms, but only include the valence electrons. The total number of valence electrons summed together is equal to the total number of electrons from the atoms in the molecule. Bonded atoms share one or more electron pairs. If it's ionic, you're going to know that bond is a line. And if it's covalent, you're going to keep them in their dot form. You arrange the electrons so that each atom is surrounded by enough electrons to fill the valence orbitals. That means a full shell. So it's a duet for hydrogen because a full shell would only be 2 electrons, and an octet for the rest. So the first thing you do is find the sum of the valence electrons in a molecule. So for H2O, that's 1 valence for each hydrogen, and then 6 valence for oxygen. So 6 plus 2 equals 8. Then you use 1 pair of electrons for the bond, each between the pair of bound atoms. A line can be used to represent a pair of electrons. So for covalent right here, you actually do take it into the line, and that's HOH. Then you arrange them to satisfy the duet rule, that's 2 for hydrogen, and octet rule for all of your other atoms. See how you still have your 2 lone pairs on the oxygen? There's 4 electrons that don't participate in sharing, so they don't go into a line. So what I want you to do is practice writing the Lewis structures for each of these molecules on your own once you do it after this video is over. And then you can also have multiple bonds where they're sharing. So you count your valence for CO2. Carbon has 4, oxygen has 6, so that would be 16 valence electrons total because it's 4 plus 12. And then you show the bonds like that. That's your single first bond, but then you still have more, and then you each still have your 2 lone pairs here. So this is an example of a single bond, a double bond, and a triple bond. And that's it.